Today we are talking about the field of view for a microscope. So you need a pen or a pencil, and let's get started. Field of view. That is the diameter of the circular area you see when you look through the eyepiece of the microscope. Measuring. It is difficult when looking through a microscope to really comprehend the size of a specimen. The field of view can be measured by placing a transparent millimeter grid on the stage and comparing the specimen to the field of view at that magnifying power. So for field of view here, I'm going to abbreviate FOV. Measuring field of view. When measuring the field of view, we need to know that each box on the grid equals 1 millimeter. Because organisms we view are so small, the unit that we actually use to state our microscopic specimen measurement is the micron or micrometer. So in comparison, 1 millimeter equals 1,000 microns or micrometers. The units for micron sort of looks like a U and then an M, but the U has this little front tail situation. Okay, so here when you're converting from 1 millimeter to 1,000 micrometers, you move the decimal place 3 places to the right to get the micrometers. For example, how many micrometers are in 2 millimeters? So if you had 2, you could take 2, you put your decimal point after the number, then you move the decimal 1, 2, 3 places to the right, and you fill the spaces in with zeros. So 2 millimeters equals 2,000 micrometers. 3.5 millimeters, you move the decimal 1, 2, 3 to the right, fill in with zeros, and 3.5 millimeters equals 3,500 micrometers. On the bottom here, we're going to practice with some estimating the size. So looking at the picture on the right, which is actually down here, you can see that the field of view is 2 millimeters. So FOV is 2 millimeters. So it's telling you that from one side of the field of view to the other is 2 millimeters. So we need to estimate the size of this cell. When estimating, I like to cut the field of view in half to start, which means this half is 1 millimeter and this half is 1 millimeter. So now this cell, you can see, is less than 1 millimeter. So it is approximately half of that, or 0.5 millimeters. When you're all set, please flip to the back. So on the front, we talked about that millimeter grid you could use. The millimeter grid is great, except that, excuse me, it's difficult to use it on high power. So using the millimeter grid, it is fairly simple to find the field of view of low power and medium power. Finding the field of view on high power is much more difficult because the diameter is less than 1 millimeter. So the grid that we will be using to measure specimens, each box on that grid is 1 millimeter in diameter. However, the high power field of view is less than 1 millimeter, so the grid is not useful at all. Something to think about. What happens to the diameter of the field of view as you increase the magnification? So as you go from low power to medium power to high power, you increase the magnification, but the field of view decreases. You increase the magnification, so it makes the specimen appear larger, but you see less. The good news is that even though we can't use the grid to measure the field of view on high power, there is a formula, a proportion we can use in order to accomplish that. To determine the high power field of view, we can use a proportion based on what we know about the low power field of view. The proportion is given here. It is the high power field of view divided by the low power field of view, okay, equals the low power magnification over the high power magnification. So I'm going to move this up a little bit so we can still see the proportion and we can see the word problem. Assume that a low power objective is 10x and the high power objective is 40x. On this microscope, the diameter of the low power field of view is 2,000 micrometers. What is the diameter of the high power field of view? So we already have our proportion here. So let's draw a line, an equal sign, and a line, so we can substitute in our numbers. The high power field of view is what we are looking for. So that nothing gets substituted there. So I'm going to abbreviate with HP, high power, FOV. That's our unknown today. The low power field of view, they tell us, is 2,000 micrometers. You want to make sure you include units here. The low power magnification is 10x. The high power objective is 40x. So we've set up our proportion. It's now time to solve. So what I like to do first is see if I can simplify any numbers. So over here, the units, you can simplify and cross off, and the zeros. So you're left with 1 over 4. I'm going to make this bigger a little bit. Okay, so we've simplified this side. And now when you have a proportion here like this set up with the equal sign in the middle, you need to cross multiply. So that means you need to multiply this together. Okay, so you have the high power field of view times 4. So I'm going to put HP FOV, put it in parentheses, times 4, equals, then you have to multiply this information, which is 2,000 micrometers times 1, which is just 2,000 micrometers. In order to get the high power field of view, our unknown by itself, we need to get rid of this 4, and to do that we need to divide by 4 on each side. These simplify, okay, they cross out, and you're left with the high power field of view equals 2,000 divided by 4 is 500 micrometers. So even though we cannot use the millimeter grid to measure the high power field of view, we can use this proportion. And as long as we know some information about the low power field of view and the magnification of the objectives, you're able to figure out the high power field of view. That is it. Thanks so much.